athletes, it's Miss Smith from Sinclair Elementary, and we are tackling an awesome topic today. It is decimal division, and I want to take time in this video to really walk you through the standard algorithm, and that's the formula for how to do dividing decimals. So grab something to write with, follow along, pause as you need to, and just as always, this is a huge skill for you to have your whole life. So buckle up. It's going to be if this was a workout, I would say it would be a sweaty one, but it's a math workout. So you're going to use your brain a lot and you're going to feel really proud of yourself when you're done. So once again, we're going over the standard algorithm, and that means the formula, the standard steps. We're not going to be using any models today. I'm taking you through the regular steps on how to do long division with decimals. Okay. There's a few fun things that I'll walk you through. But most importantly, just be ready, be positive toward learning, and you'll get it. So we're gonna start with an easy example, okay? And I wanna take the number, but before I actually give you that, let me talk about this. This is a great skill to have, to know that if you're wanting to split the cost of something with one of your friends or relatives, you can figure out that if you're buying something and you're all there, how much money everybody should pay. So for example, let's say that something costs $2.50, okay? And two of you and maybe a friend are at the store and you wanna know how much each of you would pay if you were to split the cost of that item, okay? So $2.50 divided by the two people who are gonna pay for it. So what you're gonna do, and this is gonna seem easier than you might think, with that decimal, you might be wondering, oh no, what's it doing there? Like, I'm not used to dividing with a decimal there. So I've created, the simple way that I teach it is that we move this decimal up here. And for fun, over the years, as I've taught this, I tell kids that it's kind of like if you were in an elevator. You know, an elevator goes from the bottom floor to the top floor of a building. It starts at the bottom usually. If you're going down, that's different, but pretend we're on the bottom floor of a building, a tall building. And if you got in an elevator, you would ride it to the top. So I always say elevator up, okay? The elevator goes up. So you're simply gonna take this decimal and elevator it up to the top of this division sign. You literally just moved it right above you. You're not moving it to the side, not over to this way, not this way. You're not making it disappear. You're simply elevating it up right here because that's where it's gonna go in the answer. How easy is that? You just push it on up, okay? So once again, this is called the standard algorithm. So once you've done that, we will divide with long division as normal. So I'm going to ignore this the same way I do when I'm multiplying decimals. I'm gonna just deal with it later because it's already placed right where I need it. So once again, where you see it, it goes straight up at the top. Do not move it around any other direction but up. So now you simply do long division. How many groups of 2 go into 2? I'm gonna underline because once again, when we do long division, I taught you this before, with long division, I want to see who remembers the rule that I taught you about long division. Hopefully you remember how much I have told you this. 1 digit at a time. I've said this to you. You've also heard me say something like digit by digit. Digit by digit. There is nothing more important than taking your time in math, going slow and steady, digit by digit, one step at a time. When we rush things in math, we get lost, we get scared, we get nervous, we forget what we're doing, we can't visualize what a reasonable answer would be. So if there's anything I would ever want a math student to really walk away with, are these important things. Go slow, go steady, one digit at a time, digit by digit. However you say that to yourself, Just slow down. Everything can be done if you just go slow. So if we come back to this, I'm purposefully gonna go very slow today. How many groups of 2 go into 2? Remember, digit by digit. How many groups of 2 go into 2? 1. So then I do the 1 times 1 group of 2 is 2. So now I can subtract 2 minus 2 and get 0. Remember, I've already moved the decimal, so I don't need to worry about it anymore. I'm gonna bring down the 5, and now I have a new number. I will underline it. 5. How many groups of 2 go into 5? 2 groups of 2 equals 4. That's the closest I could get. 5 minus 4 would be 1. And I still have a 0 to bring down. 10. Okay, now I have 10 divided by 2 is 5. 5 times 2 is 10. There you go. $1.25 is how much each of you would pay if this was an example that asks us to talk about how many people, if there were 2 people, were paying for $2.50. All right, we're gonna move on. 1 digit at a time. We're gonna stick to that, okay? Elevator up. And just for fun, let's draw a box and chop it in half. And I do this every year because I think it's kind of cool. I'm actually going to draw an elevator. Hopefully you've seen an elevator before, but some elevators have one sliding door and some come together. So we're going to pretend this is an elevator doors. And I'm just going to put little doors like that, even though they don't have doorknobs. But we're going to pretend elevator. And I want you to just literally visualize that the elevator is going to be going up. We don't really need these, I guess. Elevator doors, and they're going to go up. So next time you're in a building that has elevators, be like, oh, this is how I remember division. So let's try another. Let's try to divide several numbers. Let's try if something, let's see, 20.95, let's say that's $20.95. And this time, let's pretend you had 3 friends with you to share that cost. So perhaps you were buying something that was $20.95 and you need to divide it by 3 people. Okay? So how many, digit by digit, I'm going to start with the first digit. How many groups of 3 fit into 2? Oh, I surely hope you would have stopped me by now if this was a real lesson. What did I forget to do? First thing you do is you move decimal point up above on quotient line. And what do I mean by quotient line? The quotient, if you recall, is the answer to a division problem. So the quotient goes up here. So just as I mentioned in my note here, I moved the decimal point up to the quotient line and it disappears. I moved it because the new location where it belongs, it permanently will belong up there. You will not move it, you will not touch it, that's where it belongs. So that's what's so great, is that once you move it to the quotient line, you're fine. All right, digit by digit. 3, how many groups of 3 go into 2? None. 0 groups of 3 is 0. 2 minus 0 is 2. Bring down another 0. Now I have a 20. How many groups of 3 fit into 20? So the closest I think I could get is 6, because 6 groups of 3 equals 18. 20 minus 18 is 2. Remember, I don't have a decimal here, so I'm moving on to the 9. 29. How many groups of 3 fit into 29? I believe it's 9. 9 groups of 3 is 27. So you should be here. 29, or 9 minus 7 is 2. And then 2 minus 2 is 0. So I don't need to put that there, or you can. I also have a 5. Ooh, interesting. Now, how many groups of 3 fit into this? The closest I can get is 8. 8 groups of 3 is 24. Now, something interesting is happening. I have a remainder. Let me move that down so you could see a little bit more. Okay, so now I have a remainder, and that's a little bit of a troubling, kind of interesting thing. I actually can't have a remainder. I can't put remainder 1, because that would indicate that I have a remainder of a whole 1, and I do not. These are not whole numbers. Remember, on decimals. So when this happens in a division problem, you actually do something that hopefully will jar your memory of something we learned at the beginning of the year, and that is when you add zeros to the right side of a decimal, it does not change the value. So I can actually do something interesting. So I'm going to erase this because this is not correct. I can add a 0 there because remember, there used to be a decimal here. So really, I'm not changing the number. And furthermore, I've already planted my decimal place there. So adding to this won't change it. So let me add the 0. And now I have 10. Okay? But the problem is that there's no even groups of 3 that can fit into 10. The closest I can get is 3. 3 times 3 is 9. And what's going to happen, let me move that down a little bit again. What's going to happen here is I'm going to get a repeating decimal because it's just going to continue to be 3, 3, 3 on and on and on because there's no other multiple of 3 that would give me a 10. So I want to show you what happens. If I kept dividing and I kept adding zeros, I would just continue to get 3s. But watch something important here, since we know how to elevate her up. What you do in situations like that is you take this number, and what do you think you do with a really long quotients like that? What do we do when we do that? We round the answer to a place value that's reasonable. So in this case, we started out talking about money. So typically we go to the nearest cent, which is the hundreds place. So I would take my quotient. The quotient is the answer, 6.98333. This is called a repeating decimal. It means it would go on and on. It would never turn up to be something equal with no remainder. So it would go on and on and on. So since we're talking about money, I'm gonna stop at the hundreds place because we don't talk about coins past the hundreds place because there aren't any. So I'm gonna circle this and I'm gonna round to the nearest cent, and I know that the 3 is not big enough to bump this up, so my answer would be $6.98. This would be my rounded answer using this decimal. And let me write that down for you. It's called a repeating decimal. It's called a repeating decimal. So this right here, you would take to the nearest hundreds place, okay? So that would be really how you do it. Thank you so much for watching that. Okay, we're gonna try another and move on, okay? So hopefully this is starting to make sense. You move up the decimal and you simply repeat the long division process. So let's come up with an example. I'm gonna say that, let's make up an example, okay? We're gonna do one. Sally wanted, write this down, to buy a sketchbook. Do you know what a sketchbook is? It's like a book that you draw and sketch and practice. She wanted to buy a sketchbook. It cost $24.95. She gets $4 in allowance for chores each week. How many weeks will it take for her to save enough money? To buy it. So, we just wrote down an example. Okay, let's read it again. Sally wanted to buy a sketchbook, so she's buying something. It costs right now because she hasn't paid for it yet. It costs $24.95. So I can box that. That sounds important, right? She gets $4 in allowance for chores each week. So every week that she helps her family with some important chores around the house, she gets $4. So now I'm going to look at what they're asking me. How many weeks will it take for her to save enough money to buy it? Interesting. So which part, what kind of information can we think about here? We have a total cost and we have some money she gets each week. So if you're thinking this through, hopefully you would have seen that we take the cost of this and divide it by 4. And if we take the cost divided by the amount of money she gets each week, then we will know how many weeks it would take her. So let's do that. I'll do it here so you can see it. So we had let me make sure you can see that, $24.95. And that's where I got that from the problem, divided by the amount of money she gets each week. I sure hope I have enough space. I'm actually gonna move it over here, excuse me. Let's do it in blue. $24.95. Make sure y'all can see that. $24.95, excuse me, divided by 4. And once again, I'm getting this information here. $24 divided by 4, okay? So we're gonna go digit by digit. How many groups of 4 into 2? None. Our decimal elevator's up. I'm gonna do it in a different color. 0 groups of 4 equals 0. 2 minus 0 equals 2. Bring down the 4. Now I have a new number, 24. How many groups of 4 goes into 24? And that would be 6 equal groups. So we can put the 6 right above, leave that decimal right there. It's not bothering you. You would do it just like regular long division. 6 times 4 is 24. 24 minus 24 is 0. Bring down the next number. Once again, you're ignoring this decimal because it's already been taken to the top of the quotient line. So bring down the 9. Now we have a new number, 9. How many groups of 4 go into 9? 2 is the closest we can get. 2 groups of 4 equal 8. 9 minus 8 is 1. And I'm going to bring down the 5. And my new number is 15. How many groups of 4 go into 15? 4, 8, 12, 16 would be too big, so it would be 3 groups of 4 is 12. And once again, we are stuck with a remainder. What do we do when there's a remainder? we have no problem adding a 0 because it does not change the value. So that gives us another 0 and turns our number into 30. How many groups of 4 go into 30? 7 groups of 4 equals 28. Now I have 2. I can add another 0. Now I have a 20. A 20 is good because I have equal groups. How many groups of 4 go into 20? 5 groups of 4. 5 groups of 4 go into 20. Now I have to, that's how long that problem was. Look, you now have a quotient and no remainder. So I'm going to move this over here so we can all see it. My quotient with my decimal in the correct place is 6.2375. Now, let's go back to the problem and really think about what they're asking us. How many weeks will it take for her to save enough money to buy it? Our answer is 6.2. So what is 6.2375 weeks? Like, I don't know what that is, but I do know that it won't take her 6 weeks because it's going to be longer than 6 weeks, right? So wouldn't she need to do an extra week's worth of chores to make sure she had enough money? So if I have 6 and some time in weeks, I need to think about this as rounding to the nearest, going up to the next week. Because if I round this down to 6 weeks and I tell Sally, oh, as long as you work and do your chores for 6 weeks, you're gonna be good. Because 6 times 4 is only 24. So once again, if we mistakenly answer this question by saying 6 weeks, we would be wrong. This is not 6 weeks. This is 6.2375 weeks. We have to think logically and reasonably about what they're asking us here. If I say 6 weeks, 6 weeks times 4 each week would give me 24. I would be 95 cents short. And also, don't we most of the time have to pay for tax and time? I mean, just there's other costs. So if you were answering this question using reasonable estimate, I would say that I would bump this up to 7 weeks, right? Because that would be a logical answer. Because we could then say 7 weeks times the $4 she gets every week would give her $28. And if she has made that plan for herself, she would have $28. She's gonna go to the store with $28. She's gonna pay for this sketchbook that costs $24.95 plus tax, and she will definitely have enough, and she'll probably have some change too. So this is a great example of how to reasonably work your way through the problem. This also helps you to think, does it make sense that it would take her that long? And the answer is yes. If you would have gotten an answer that said 50 or 60 weeks, you would logically know you made a mistake in your math because it couldn't possibly take that long if she's making $4 every week. So I challenge you that as you're working on dividing decimals, and particularly as you're working through word problems, be very careful about thinking, does this make sense? In real life, would it really take her 50 weeks or a year to save for a sketchbook? And the answer should be no, unless she's, getting like a quarter a day or something. So really think this through. So before we end our session, I want to do one more with you. And I hope you're understanding the steps here. And once again, we are learning the standard algorithm of decimal division. Okay, this will be really good for you to learn. Okay, and just like with anything else that I've taught you, if you ever start a division problem and you get lost along the way, sometimes students get frustrated when their answer is not correct. Just scratch it out and start it over. You don't need to sit there and stress about that. You need to just move on. You're gonna be great. Okay, just start over. So let's try if we had something, let's do a larger number. Let's do a 4-digit number. Let's do 4. So let's do 36. Actually, I want to change that. We won't do money this time. 369.8 divided by 2. Or, let's make that harder, right? Let's do 12. We can do hard things. We're gonna end the note, a high note. We're gonna do a hard one. 369, write this down on your paper, 0.8 divided by 12. So as we have been doing with long division, when we get 2-digit divisor, we make a T-chart because it will help us to stay accurate. And we're gonna be reusing this divisor quite a bit. 1 times 12 is 12. 2 times 12 is 24. 3 times 12 is 36. And if you didn't know that, just come over here to the side and do it. It's okay if you need extra work on the side to build a T-chart, okay? I'm gonna stop here and let me go ahead and do 4 times 12 because I know that's 48. I'm gonna stop here. If I need more, I can always come back later. So let's take a look at my divisor. How many groups of 12 go into a 3? Remember, digit by digit, none. Let's move on over here. 12 into 36. Well, I can see it here that it's 3 groups of 12 make 36. Oh, well, isn't that convenient? 36 minus 36 is 0. I'm gonna drop 1 number. How many groups of 12 go into 9? None. Oh, gotta put this up here. 0 times 12 is 0. 9 minus 0, 9. Now I'm gonna drop this and I'm gonna have 98. Interesting. So I don't know, I'm gonna need to extend my T-chart. So I know 5 times 12, I'm gonna add 12 to this and that would give me 60. And if I add 12 to this, I'm gonna get 72. And if I add 12 to this, I'm gonna get 84. I'm just doing that in my head. You guys can use your paper. So what's 84 plus 12? That would give me 96. 8 times 12 is 96. That's pretty close. So 8 groups of 12 give me 96. And now I have a 2 as my remainder. Can I have a remainder with a decimal? You got it. You cannot. So I'm going to add a 0. How many groups of 12 go into 20? 1. Group of 12 go into here. 20 minus 12 is 8. Got to add another 0. Now I have 80. Can y'all see that? 80. The closest I can get is 84. I'm sorry, 72. 6 times 12 is 72. I have to fix it. This is getting long. I even have to adjust my camera for you guys. So you would go on and on and on. But the great thing is that I'm going to be keeping an eye on this quotient up here. And once I get it long enough, I usually don't need it to be much longer than that. So I'm going to stop. I can actually just stop. So I'm going to come over here, and depending on the nature of my answer, I'm going to round it to a reasonable place value. So in this example, I'm going to round to the nearest hundredth because that's where my number can go. So 30, I'm going to round to the nearest hundredth. So I'm going to take the 6 and bump this to a 2. So 30.82 would be my final answer. Very cool. And notice my decimal had no trouble figuring out where to go. I simply used my funny little elevator rule and I just took it right on up there. Okay? So practice, guys. You're going to get so many different problems, but this will help you make decisions because you can split the cost of things with other people because now you know how to divide decimals. So work hard. I hope you guys have an awesome day. This is one of those lessons that you might have to view more than once. Work through, practice each example I shared with you. And most importantly, when you get those word problems like I showed you, look and think, Is it reasonable? Does it make sense that my quotient would be this? Does it make sense? Okay guys, you did amazing. I have loved it. Standard algorithm for dividing decimals. I hope you guys have an awesome day.